Now, suppose you are given data. You're going to learn how to move from just writing expressions to actually solving for the order and rate constant using experimental data. So that's what we're doing here now. So for your practice problem, you're going to do a rate law determination, okay? And in each of these problems, I'm going to give you experimental data, and you're going to have to find out the rate law, the K constant, and the order, all right? So here is your first part of information right here. First off, let's take a look at the decomposition of hydrogen peroxide, right? What you noticed here, if we look at just these first two data points right here, what you notice is that your concentration, see this? It goes from 0.10 to 0.20. It doubled. See that? Let me zoom in a little so you all can see that right there. It doubled. And because it doubled from 0.10 to 0.20, what did you notice here about your rate? It also doubled, okay? It also doubled. Now, because both of those have doubled, we now need to do what? We need to write the order with respect to hydrogen peroxide. We've got H2O2. See that? If you notice here, the concentration doubled right here from 0.10 to 0.20. All right? So it doubled. Now, the rate also doubled right here. It also doubled. So because both of those doubled, I'm going to show you all how to write the rate law, okay? So you want to do several different types of observations. Here, we have to say that the rate equals your K times, and we're only looking at the reactant side right here. So what you got right here is the rate law, okay? Because they both doubled, because your concentration doubled and your rate doubled, this would be first order, okay? This would be first order. So back to our question right here. It says, what is the order with respect to H2O2? Is first order because they both doubled. And because they both doubled, that gives us the first order. Our rate law is only respective to the reactant. So in brackets, I put H2O2. Now to find the K, because over here it says calculate K, here's how we're going to do this. K equals, and I'm going to have to break this formula down because I want to make sure that you guys can see exactly how this works. Because we're looking for K, we're going to divide both sides by H2O2, okay? So right there, we're going to cancel those two sides out. And so our K that's left over here is equal to the rate divided by H2O2. See that? Okay. Now, why am I showing this to you? Because it asks us to find the rate, or I'm sorry, the K. And because of that, we're going to put up here on the very top the rate here from our data. Okay. Let me go back to our data so you all can see that. Okay, see that right there? That 0.012, we're going to put that on the very top, and on the very bottom, 0.10. So we're going to divide these two numbers right here. Okay, you see that? We're going to divide both of those numbers right there. Okay? So I'm going to put 0.012 and put your units there. Okay? Units are important. You're going to put your units there. Molarity per second divided by 0.10 molarity. Now, when we divide those two numbers, again, we're going to cancel out our molarities because we don't need that anymore. And our K here is going to be equal to, let's go ahead and divide those numbers, 0.012 divided by 0.10. And we get 0.12 per seconds. That's what that seconds with the -1 means, per seconds.